Hello, my name is Poeschko. I work for Wolfram Research, and today I'm going to talk about cloud notebooks, what you can do with them, and what we've been working on over the past year. Okay, let's get started. Hello and welcome. My name is Jan. I work on cloud notebooks, and today I want to talk about what's new in our world. But first of all, I want to introduce the concept of cloud notebooks in general. So you're probably familiar with notebooks in desktop Mathematica, where you have your local installation of some Wolfram system, and you work with notebooks to create documents, do your computations and so on. And our goal is to bring that same power, that same concept of notebooks to the web, so that you can, on the one hand, edit notebooks just in a web browser, but on the other hand, and that's maybe even more interesting, to deploy notebooks to the web so that other people can look at them and can interact with your notebooks. Again, this is, the idea is that you don't need any local installation of Mathematica or anything. There's no plugin running in your browser. It's basically just a website. And by the way, this is also a cloud notebook. So I'm running Google Chrome here as my web browser, and it's connected to a local private cloud, you could say. It would work pretty much the same on wolframcloud.com, just that I wanted to make sure that we don't run into any network issues, and also I'll show some features that are not shipped to the public cloud yet, so that's why I'm using my local version. So yeah, that's a cloud notebook in slideshow mode. And as usual, you can type things here, some text or some computation, and then when you press Shift-Enter, you get back a result. You can do more complex stuff, of course. It's connected to a kernel running on a server in the Wolfram Cloud, in this case on my computer. So you can do some math, and if you get back some more complex formula, it renders right in your browser using our JavaScript front end, basically. And this is also not an image, so if I exit full screen mode here and resize the window, this will resize accordingly and line wrap. We have support for graphics, both two-dimensional and three-dimensional. So if we have something like this, it takes a little while to evaluate, I think. You can take this and rotate it interactively. And of course, we support various interactive user interface elements of notebooks. So in a simple case, it could be like a button here that when you press it, prints a large number. But you can build more complex user interfaces, either using low-level constructs like button and dynamic module and so on, or there is a very nice high-level sort of function that constructs user interfaces for you, which is manipulate. So if you do something like this, you get back a manipulate that is interactive right in my browser now. I can drag the sliders, I can move around the locators, and it basically just works. So yeah, that's the general idea of cloud notebooks. Now I want to highlight some things that have happened over the past year or so. And very big focus of ours has certainly been stability to make the whole system more robust. So a few things you shouldn't see anymore now is this warning that says that your session timed out and then you had to refresh the whole page. That was a bit annoying. There was also a problem where if you kept the manipulate open for a long time, sometimes you got initialization timed out. And they all had to do basically with the client and the server getting out of sync after a while, and then there was no good way for them to communicate anymore. They were actually separate issues and really not trivial to solve, but I think we did now, and so these problems should be gone now. And of course, we're making various improvements to make all of notebook rendering more robust, but we realized that there's probably always going to be some limit of what you can do in a web browser, because after all, it's a very hostile environment to do this sort of stuff in JavaScript. But then we just want to make sure that even if one cell is maybe problematic, you can still view the rest of the notebook at least. Or even better, we might want to try to show the cell, but it's just not going to be interactive. So the idea is that if you have a very large cell or a very complex one, we detect that. And so in this case, it's hitting the output size limiter first, which you might know from Desktop Mathematica. But once I press show all here to basically render 3,000 buttons, it's gonna give up on trying to render that interactively and just render an image instead, which is generated on the server where we have a bit more power, and then rendering an image is easy on the browser. So it won't kill your browser tab and so on. So the nice thing is that you can still see the buttons, but unfortunately you won't be interact with them in this way. Once you try to do that and you click here, it will tell you, it's a bit tiny, but it will tell you that the cell contents are too large for interactive rendering. And if you're brave and courageous, you can click try to render anyway, taking the risk that it might freeze your browser, or at least the one tab. Then it might take a while. You can also stop this. But yeah, in this case, it wasn't even too bad. It comes back with the interactive result. The buttons don't do anything, but at least you can see the hover effect. Maybe. So yeah, that was, or will be one way in the upcoming version of the cloud, how we try to make notebooks more robust and at least showing you something. As already said, we're constantly working on performance as well. One aspect of this is that we're trying to show you the notebook as soon as possible. And a way how we address that is that we generate static HTML on the server that we can ship to the client immediately as you open the notebook, and the client, that is the browser, can render that very quickly. But in the background, it will download all the necessary JavaScript and then execute that to render the notebook interactively. So the point is, again, that you see something right away, like any other web page, basically, but then it might take a little bit for it to become interactive. And we've had this system in place for a while and made various iterations on it, improving it. So it should be quite robust now. One thing that you might still sometimes see is a small difference between the HTML that's generated on the server versus the thing that's produced on the client side. And that's when you get things shifting around a bit as the notebook loads. This is exactly what we're working on improving to minimize these differences between what we call the cache and the live version. Yeah, so that's in terms of pre-rendering of notebooks. Also, we're constantly working on our JavaScript code to make it faster, to optimize how we render stuff in the browser. So I just did a recent optimization that, at least for certain box structures, brings down the rendering time to about 30% of what it used to be. So 3 times as fast. And it's probably, I think over the last year, we've made even more like this. So I think it's safe to say that it got faster by a pretty good factor. And then on a slightly higher level, it's also important, particularly in the cloud, to think about the network. So in the desktop version, you don't really have that problem because the front end and the kernel usually run on the same machine. So any transaction between them is pretty fast. Usually the computation itself is the bottleneck. But in the cloud, every time we talk to the kernel from the client, we need to make a network request, and that has a big latency usually. So what we thought would make sense is to try to batch multiple evaluations into one single HTTP request to only get hit by the latency once. And one example where you could see this is if you have a list of many dynamics. They basically want to try to resolve at the same time, but what used to happen is that they would really go one after another and waiting for the previous request to complete. But now this should be almost instant. And maybe it's a bit cheating because I'm running on a local machine, of course, but you can see this in what we call the notebook dev tools. You can open them with a special keystroke, and then you get a list of everything that goes on between client and server, particularly the evaluations. So if I make a change now, you will see, a bit tiny, sorry, it made one evaluation for the whole cell, and then it made 3 subsequent evaluations to resolve these 50 dynamics. It's a bit non-deterministic, depending on how rendering catches up with network requests, but it's usually going to be much less than the number of dynamics. And maybe this is a bit of a contrived example, but it will be very useful for typical manipulates as well, where you probably have a lot of controls that all at least need to initialize once, and now that can all happen with a single or at least a few network requests. All right, even more along optimization, and this one is really highly experimental, but I think it's pretty exciting, so I wanted to still show you this. Here the idea is that we get rid of the network request completely. The idea is that you can create a manipulate, and we compile the body of the manipulate into WebAssembly using the upcoming compiler technology for the Wolfram language. And so then the browser can update the manipulate without going back to the server and the kernel. This is just on my computer. I need to enable it with this flag. But then once we create the manipulate, might take a little longer because of the compilation initially. Yeah, so even without the DevTools, you should see it's pretty smooth. I mean, maybe not as nice as on desktop yet, but very comparable, I would say. And the nice thing is that this would work just the same on wolframcloud.com, because this is not getting any advantage from running on my local machine now. And as you can also see here in the DevTools, there's not a single request coming from the client to the server. It's just updating it on the client side. We made this work for a very special case of manipulate, where you have plot of a function that we can compile. And I think for that, it's probably good enough that we can ship this as soon as the compiler is ready. But then we'll have to think about how to generalize that. That will probably not be easy, but at least for certain manipulates, you can expect a good speed up from this. From very bold optimizations to some design details that we've been working on. We've been working on all the controls, updating their design, taking care of little things like making sure that the buttons stay in their pressed state while the evaluation is going, to give you more feedback. Some people have asked for that. We've been also working on better rendering of what we call growable characters, like when you have a radical and something inside. It depends on how large that thing inside is, of course. So if I resize the circle, the radical resizes as well. And we had this before, but what we were doing is we were stitching together many little characters, and sometimes you could see artifacts from that, and anti-aliasing comes in and so on. And it was also slower because the browser had to do more stuff. But now we're creating a single path and using SVG to render this whole thing. Another little detail, also using SVG rendering now, is cell brackets. Maybe if you are using a high resolution display, you might notice that these look much better now. And we support things like various decorations of cell brackets, in this case for the traditional form. It's very hard to see, but you get a little dotted border as well. Another feature that's coming soon is dynamic geographics, and it takes a little bit to evaluate, where we figured for this particular thing it makes sense not to use the whole box rendering stack that would be used by Desktop Mathematica, but we have our own custom JavaScript implementation for maps. Still evaluating. Suspiciously slow. This will use the network. Okay, so there you have a map with some polygon on top of it, and you can interact with this, pan around, zoom in, and so on. And yeah, this is working in cloud notebooks now. I think the function is still experimental anyway, but if you want to start using maps in notebooks, that's probably an interesting thing. Finally, I want to talk a little bit about typesetting in relation to the editor. And the sad news is that we don't support it yet completely. So, in Desktop Mathematica, you have a very nice editor where you can enter subscripts, superscripts, fractions, grids, and so on. We're still working on the foundation to make that happen in web browsers as well. It's just not easy at all. But in the meanwhile, I thought I'd show you a few things how you could sort of work around that. And one thing we've had for a while, I think, is a way to convert from input form to standard form. So input form is a thing where I would just type x/y, whereas in standard form, this turns into a fraction, an actual typeset fraction. And this is in the cell gear menu under convert to standard form, and there you get a fraction. So that's nice if you have a single, a whole cell that contains some math that you could represent this way. But I can even take this now, so I can select the cell bracket and then press Command-C to copy it to the clipboard. And I could paste this anywhere else, for instance, in a new input cell. And then I can also edit around that. So I can here type something like this. I can paste it another time. I just can't cursor inside of this construct. It stays as an atomic blob, but I can delete it as a whole if I want to. And the nice thing is that this has, of course, the right semantics. So if I evaluate this, it realizes that this is not just an image or anything, but it is actually the fraction x over y. We don't yet, but that's also coming. Yep, that would help with this too. Evaluate the place. Yes. So that would do the other way. And we're just about to hook up shortcuts for this as well. We don't have them yet because it's, again, a bit tricky in the browser. It won't let us use the ones we want, but we'll find other ones. Another thing that's coming, probably not too soon, but not too far away either, I hope, is a way to input tech code, which probably many people are familiar with, and that's also a nice way to write formula. And it's also easier for us because we only have to worry about a linear input string as opposed to this 2D typesetting editor. So the idea is that you press Command 4 or Command $, and then you get this little input field, similarly to control equals for linguistic input. And here I can now type \fraction xy, and when I resolve it, it also turns into the typeset construct. And again, this has the right semantics, of course. So yeah, that's going to be coming as well. I think this will probably land in the cloud first because it's more important for us, because there is no other good way to input typesetting constructs, but I think it is definitely planned for desktop as well. I think it will be a nice feature in both places. Yeah. It should, yeah. Yeah. Cool. And yep, that's a few things we've been working on. It's a very active area of development, so I couldn't show everything. Here's a few related talks about the compiler if you're interested in that, or just other front ends or notebooks in general. And shameless plug, if you're interested in more practical applications of cloud notebooks and how to build something like a blog with them, I'll do another talk on Friday about that. Thank you very much.